This is Ms. Steele's Precalculus, section 9.5. We're going to be discussing the algebra of matrices. So, anytime we talk about matrices, we always label them in terms of rows by columns. So, looking at matrix A, notice there's 2 rows and 2 columns. So matrix A is called a 2 by 2 matrix, and this is the dimension of A. B, notice there's 2 rows and 3 columns. So we refer to B as a 2 by 3 matrix, where 2 by 3 is its dimensions. For C, you can guess, since it's 3 rows and 3 columns, we refer to that as 3 by 3. And D is the same, so it's the same as A, so it's a 2 by 2 matrix. So the rules for matrices. For adding and subtracting, matrices must have the same exact dimensions. So an example would be adding A plus D. Since A and D are both 2 by 2 matrices, we are able to add them. A non-example would be adding A plus B. Since they do not have the same dimensions, we are not able to add them. For multiplying, we will be taking the columns of the first matrix, the columns of the first matrix must equal the rows of the second matrix. So for example, if we have a 2 by 3 matrix, we're trying to multiply that by a 3 by 4 matrix. Since those two inside numbers, the 3 and 3s, are the same, we are able to multiply them. The result of our matrix will be the two numbers on the outside, so the 2 by 4, which is how we get the 2 by 4 matrix. So this will be the result of X. Another example would be if we were multiplying a 3 by 4 matrix, and we are trying to multiply that by another matrix. That matrix must have 4 rows. So this could be a 4 by 1 matrix. So since these are the 2 4s are the same, we can look at the outside entries, and the product of those 2 matrices would end up being a 3 by 1 matrix. So it does get easier when looking at some examples. So let's take a look at example 1. Using the same matrices that are listed on the top of your paper, it asks us to find A times B, first without a calculator. So notice that A is a 2 by 2 and B is a 2 by 3. So since these two numbers are the same, we can look at the resultant, and we know that AB will end up being a 2 by 3 matrix. So I'm going to give myself enough room to write 6 total numbers in that matrix. 2 by 3. So when looking at, when I'm trying to find the top entry, my top left entry, I will be taking the first row and multiplying it by the first column. So to find my top left, or the top left entry, it's the first row by the first column. So we'll be taking 6 times 1 and adding that to 7 times negative 2. 6 times 1, we know is 6. 7 times negative 2 is negative 14. 6 minus 14 is negative 8. So my top left entry will be a negative 8. Now if I'm trying to find the first row but middle entry, I'll still be using that same 6, 7, the first row, but instead, because I'm trying to find what's in my first row, but I'm trying to find my middle column. So I'll be using the middle column of the second entry. So I'll be multiplying 6 times 0 and adding that to 7 times negative 3. 6 times 0 is 0. 7 times negative 3 is negative 21. So the middle entry of the top row is a negative 21. Now continuing straight across, if I want to find the top right entry, I'll be using that first row, but last column, so this would, I'll be taking my 6, multiplying it by 5, and adding that to 7 times 1. 6 times 5 is 30. 7 times 1 is 7. So our top right entry is 37. So now to find the second row, first column, we'll be taking the 2, 3, multiplying it by the 1, 2. So then we'll be taking negative 2 times 1, adding that to 3 times negative 2. Negative 2 times 1 is negative 2. 3 times negative 2 is negative 6. So the bottom left entry will be a negative 8. If you can continue on, if we want to find the middle column, but second row, we'll be taking the negative 2, 3, multiplying it by the 0, negative 3. So negative 2 times 0 plus 3 times negative 3, which is 0 plus negative 9, which is just negative 9. And then lastly, for the last one, we'll be taking negative 2 times 5, adding that to 3 times 1. Negative 2 times 5 is negative 10. 3 times 1 is 3. So negative 10 plus 3 is negative 7. So our matrix AB has a dimension of 2, is a 2 by 3 matrix, and its entries are negative 8, negative 21, 37, negative 8, negative 9, negative 7. So next we're going to take a look at how we can use a calculator to do this, the same thing. I'm just going to close off my matrix here. So if you do not have a graphing calculator, you will either be able to borrow one from a friend. If you are able to borrow one from a friend that's not in this class, that would be the most preferred. Otherwise, you can always talk to Miss Steele about figuring out a plan, either borrowing it from her or a teacher. So for this, I will be using a TI-84 plus C, but most graphing calculators should be fairly similar. So to type in your matrices, first I want you to notice where the matrix button is. If you go down to where it says x to the negative first power, that inverse function, right above it in blue is where it says matrix. So I'm going to go ahead and click the second key and click matrix, and this is where a bunch of different matrices pop up. So I'm going to, since I want to type in my matrix for A, I'm going to go over and click edit, click enter, and since A is a 2 by 2 matrix, I'll say 2, enter, 2, so now I'll be able to type in my matrix. And anytime you type in your matrix, it goes straight across. So it goes by rows and then it jumps down to the second row and across. So it'll be a 6, enter, 7, enter, negative 2, enter, and then 3, enter. So now I have my matrix for A. Since I will also need my matrix for B, I'm going to go ahead and click second matrix again, go over to edit, and down to B, and click enter. Since B is a 2 by 3 matrix, I'll change that, so it's a 2 by 3, and now I can go ahead and type in my numbers I need. So 1, 0, 5, negative 2, negative 3, 1. So once you have all of these numbers typed in, we need to go back to the home screen. So if you see where it says mode, right above in blue it says quit. So we're going to go to second mode, so it goes to quit, and now we're back at the home screen. To multiply our two matrices, we need to go to second matrix again, and then once we're hovering around the matrix A, we can click enter, then multiplied by second matrix, scroll down to where it says matrix B, click enter. So now we have matrix A times matrix B, and if we just click enter, it shoots out a matrix. So our matrix will be for a times b, -8, -21, 37, 8, -9, -7. And if you notice, this is exactly what we got when we calculated this by hand. For the next example, we are asked to find 7 times a. This is called scalar multiplication. And anytime we have a number out in front of matrix, that number has to get distributed to every single term within the matrix. So 7a will look like 7 times 6, 7 times 7, 7 times -2, and 7 times 3. So then just multiplying these out, we know 7 times 6 is 42. We know 7 times 7 is 49. 7 times -2 is just -14. And then 7 times 3 is 21. So this is our new matrix. If we wanted to use a calculator to find this, we can pull back out our calculator. And we need to get our matrix back up again. So I'm going to go ahead and click 7 times, go to second inverse function until we find A. Since we're already hovering over matrix A, we can go ahead and click enter. So now we have 7 times the matrix A. Click enter. And there we go. We shoot out the matrix, the 2 by 2 matrix, 42, 49, -14, 21, which is what we had on paper before. When using a calculator, we ended up with 42, 49, -14, and 21. On a test, you can always use your calculator to check your work to make sure you did your work correctly, which will just, I mean, you will still need to show your work at some points throughout the test, but you will be able to use a calculator to check your work.